Hello everyone, this is Zhiyi Cheng from Queen Mary University of London. I'm going to present our paper, Inter-Task Association Critic for Cross-Resolution Person Re-ID. If you would like to know more about this paper, or if you were interested in my works, please feel free to contact me. This paper focuses on the cross-resolution person Re-ID problem. As the person images are often captured at various resolutions, the resolution mismatch issue leads to worse person Re-ID performance due to the unaligned feature distributions of high and low resolution image pairs. Current models can be divided into two groups, and we focus on the second one that exploits the SR and Re-ID joint learning scheme. However, this scheme, with a cascaded heavy model, is limited by ineffective model training due to higher gradient backpropagating difficulty. This leads to the less compatible SR model to person Re-ID. To enhance the compatibility between SR and Re-ID, that is, to make the auxiliary task super-resolution more beneficial for the main task, we propose an Inter-Task Association Critic module in the Cascaded Joint Learning Network. It is mainly implemented in two parts by Intact. 1. Association learning, to learn the Inter-Task Association constraint with a dedicated network directly from the HR data. And 2. Association regularisation. Once learned, the association constraint is then serving as a critic to further supervise the SR model. That is, the SR model is supervised by both the super-resolution supervision signal and the extra association constraint from the main task during training. To train a model, firstly, for initialization, we train a standard person Re-ID model with HR images and the identity labels. It is then frozen during the intact training. Our model is trained alternatively in three steps. First, update the discriminator D of a GAN. It is simply achieved by a standard GAN model training. After that, 2, we update the Inter-Task Association module phi between the recognition representation FC and discriminator representation FD. This is to learn the inter-task relation directly from the HR data. And 3, we go back to update the generator G of GAN. Here, besides of the normal SR supervision, the module is further constrained by the learned association regularisation phi on the resolved images extra representations. In model training, our intact loss terms are integrated with the standard GAN optimization. With one more step, the whole model remains end-to-end trainable. For experiment, as shown in Table 1, compared to existing methods, our intact achieves the state-of-the-art performance by clear margins on all of the 5 standard multiple low-resolution Re-ID datasets. Specifically, compares to the best competitor, CAD, that exploits both SR and resolution invariant representation, intact remains a better method by only using image SR as the core strategy. We adopted a multitask learning frameworks as our base model, where SR is a preprocessing step to recover the essential details originally missing in LR in order to more accurately match HR gallery. We consider that the SR inherently may be not compatible to the identity matching task, and that is why we introduce intact as an explicit regularization for SR. Here, we examine the association between the two tasks and its effect on the overall model performance. As shown in Table 2, the SR metrics do not reflect the identity matching ability, and the SR supervision is not directly relevant to Re-ID performance. They prove that the SR task is not inherently compatible to person Re-ID and shows the need for our intact model. Our model is jointly trained by 3 main losses. Here we examined their effect. Table 3 shows that with ID loss alone, the model achieves the poorest performance. It reveals that jointly learning the standard cascaded SR and Re-ID model is unsatisfactory. Importantly, our proposed association loss brings a significant improvement, which shows the effectiveness of our regularization scheme based on the idea of exploiting the underlying inter-task correlation.